Hi, thanks for joining me. Today I'm going to be going over question 1b from MAT 2023. We're told that exactly one of these five numbers is a square number and we want to know which one it is. And we're given an option of five very big numbers and we don't have a calculator and we don't want to be working out the square roots of these numbers exactly because that would just take quite a while. We want to use some tricks here to try and work out which one is a square number. So if you want to have a go at this question, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so my thought process for this is, well, yeah, these numbers are too big to even try and work out the square roots of to see if they're an integer or not. I think a better technique is seeing if I can eliminate four of the incorrect answers. So can I prove that some of these numbers, or ideally four of them, are not square? And the answer is yes, I can. So I'm going to start with option D here. The reason I've started with D here is because I can tell straight away this is not a square number. How do I know it's not a square number? Well, the first thing I notice with this number is it ends in a 5. And that tells me that this number D must be a multiple of 5. But if it's a multiple of 5, then in order for it to be a square number, it must be a multiple of 25. Now, why is that true? Well, we're going to use a fact that if you take any square number and consider its prime factorization, then all the powers in that prime factorization must be an even number. So for example, if I take 36, that's going to equal 2 squared times 3 squared, and these powers here are both even numbers, hence making 36 a square number. But if I take a number which, let's say 112, this is going to be 2 to the 4 times 3 to the 1. Sorry, not 3 to the 1, 7 to the 1. And although 4 is an even number, 1 is not an even number, and therefore 112 is not a square number. So if you've not seen this fact before, I encourage you to have a think about why this is true. Why is it that if the powers are even, the number itself must be square, but if the powers, or at least one of them, is odd, then the number cannot be square? So have a think about why that's the case. But anyway, we're just going to be using this fact for eliminating option D and also eliminating the other three options as well. So this number here, as we said, is a multiple of 5, but it's not a multiple of 5 squared, so 25. And the reason for that is if it was a multiple of 25, it would have to end in 0, 0, 25, 50, or 75. And this ends in 35. And so therefore it is not a multiple of 25. And so therefore in the prime factorization of this number, it's going to have a 5 to the power of 1 in it. And therefore 1 is an odd number, so this number cannot be square. So we've eliminated option D. Okay, that's great. We're going to now eliminate two other options using a very similar technique. So I'm going to eliminate B and E using the same or a very similar principle, except now I'm not going to be looking at multiples of 5, I'm going to be looking at multiples of 3. So both of these numbers, B and E, are multiples of 3. How do I know that they're multiples of 3? Well, to tell if a number is a multiple of 3 or not, there's a very nice trick. All you have to do is add up the numbers in the digit, add up the digits in the number, and if that result is a multiple of 3, then the original number is also a multiple of 3. So for example, if I take the number 873, for example, if I do 8 plus 7 plus 3, I get 18. And now 18 is a multiple of 3, and so therefore this number here, 873, is also a multiple of 3. So we're going to use that technique with B and E. If you add up the digits in B, so do 1 plus 2 plus 3 plus 3 plus 3 and so on, you get a total of 24. And for E, you get 39. So 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 0 plus 0 plus 0 is 39. And 24 and 39 are both multiples of 3, so that means both of these numbers here are multiples of 3. However, they are not multiples of 9. How do I know they're not multiples of 9? Well, again, to tell if a number is a multiple of 9 or not, there's a very nice trick, and it's very similar to the trick for if it's a multiple of 3. You just add up the digits, and if the result is a multiple of 9, then the original number is a multiple of 9. So for example, with 873, if I do 8 plus 7 plus 3, I get 18, and 18 is a multiple of 9, and so therefore this number here, 873, is also a multiple of 9. However, if I took, I don't know, let's say 402, if I add up the digits, I get 6. and 6 is not a multiple of 9, and so therefore this number is not a multiple of 9. However, 6 is a multiple of 3, so 402 is a multiple of 3, but it's not a multiple of 9. So therefore, neither of these numbers, B or E, are a multiple of 9, because 24 is not a multiple of 9, and 39 is also not a multiple of 9. So neither of those numbers are a multiple of 9, hence they are going to have a 3 to the power of 1 in their prime factorization. And for the same reason, I can eliminate those two, because 1 is an odd number. Great. So now we're just left with A and C as our two potential remaining options. And we kind of stare at them and we try and see, can we implement a similar trick to how we eliminated B, D, and E? And unfortunately, the answer is no. If we look at C, for example, we go, great, it ends in a 5. Is it a multiple of 25? Well, yes, it is. So it's got a 25 at the end. So it is a multiple of 25. And then we might look at A and go, okay, cool, it's a multiple of 3 because the digits add up to a multiple of 3. But it also is a multiple of 9 because the digits add up to a multiple of 9. So we can't quite use either of those specific tricks here. So we're going to have to think of something else. And I kind of look at these two numbers and I go, well, which one is it? Well, I'm not too sure. But I do look at option A and go, okay, this is at least an easier to perhaps play with number because it's quite nice. All the digits are 9. So maybe I can think about how I could factorize this number. So it's clearly going to be a multiple of 9. So I can take out a 3 squared, and what's going to be left? Well, it's going to be 11,111,111. And this looks like it should be a multiple of 11, and thankfully it is. You might ask, how do I know it's a multiple of 11? Well, there's also a very nice trick to telling if a number is a multiple of 11 or not, and it's called using alternating sums. So, for example, if I take the number, let's go 935, if I want to tell if this is a multiple of 11 or not, what I do is I look at the alternating sum. So I put a plus sign there, a minus sign there, and then a plus sign there. So I get 9 minus 3 plus 5, which is going to be 11. And since this number here is a multiple of 11, that means that 935 is a multiple of 11. So I'm going to do the same trick over here, and if you look at the alternating sum, you get 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1, which is 0. And therefore this number is a multiple of 11. So it's going to be 3 squared times 11 times something. The question is, what is this something? Well, this is 11 million, so this is going to have to be a 1 million here. And then we've got, so that's that 11 taken care of. Then I've got 11 lots of 10,000, so we're going to have 1 million, and then 0 100,000, 1 lot of 10,000, 0 lots of 1,000, 1 lot of 100, 0 lots of 10, and then 1 lot of 1 here. So we get this number here. So 10101001. However, this number is not a multiple of 11. Because if I look at the alternating sum for this number, it's 1 minus 0 plus 1 minus 0 plus 1 minus 0 plus 1, which is 4. And that's obviously not a multiple of 11. And so therefore this number here is not a multiple of 11. But the issue then you might be able to see is, well, therefore I only got 1 11 here. And so therefore in the prime factorization of this number, there's going to be an 11 to the power of 1 in this. And again, for the exact same reason, that means that this number, A, cannot be a square number. And therefore, I'm only left with one option, option C, and that must be the correct answer. I have no idea what the square root of this number is. I could perhaps work it out if I wanted to be extra safe, but because of elimination, we know it's not A, B, D, or E. So provided the question is correct, that one of these numbers is square, it must be option C. I hope this video has made sense and hopefully you've learned something from it as well. Thank you for watching. I'll catch you in the next one. Have a great day.